Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In this class we are going to study postulates of Bohr's atomic theory. Here the Bohr's scientist suggested that what are the postulates or how the structure of an atom is described. That is called postulates of Bohr's atomic theory. The first postulates of Bohr's atomic theory is the atom consists of two parts. One is center part of the atom called nucleus and the outer region of the nucleus. These are the two parts of an atom. That is, Bohr says that it consists of two parts, means atom consists of two parts. That is central nucleus part and out of the nucleus. This is the first postulate. Then second one, the central part of the nucleus consists of protons and neutrons. Then out of the nucleus, the rest part consists of electrons in definite orbitals. These are the electrons which are revolving around the nucleus in definite orbitals. This is the second postulate. And similarly, the third one says that the mass of an atom consists only in the nucleus of an atom. Mass of an atom is consistent only the nucleus of an atom. ಅಂದ್ರೆ ಒಂದು ಆಟಮ್ ನ ಮಾಸ್ ಅನ್ನೋದು ಯಾವುದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಂದ್ರೆ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ ಪಾರ್ಟ್ ಮೇಲೆ ಮಾತ್ರ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಔಟ್ ಆಫ್ ದಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುವಂತ ರೀಜನ್ ಮೇಲೆ ಏನು ಡಿಪೆಂಡ್ ಆಗಿರೋದಿಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. ದಟ್ ಈಸ್ ದಿ ಮಾಸ್ ಆಫ್ an atom is consistent only on nucleus part of an atom. Then the fourth one, electrons are moving around the nucleus in a definite orbitals. These moving electrons having an angular momentum. That angular momentum is given by mpr is equal to nh divided by 2 pi. The angular momentum is given by mpr is equal to nh divided by 2 pi, where m is nothing but mass of an electron. We know mass of an electron m is equal to 9.1 into 10 power minus 31 kg. So this is the mass of an electron and v is the velocity of an electron, that is moving electron velocity. Then r is the radius of this orbit or any one of the orbit, that is r is radius of an orbit, and n is the integral where its value begins from 1, 2, 3 so on like that. That is integral. Then h is Planck's constant, that is 6.31. Sorry, h is equal to 6.625 into 10 power minus 10 power 31 joules second. This is the Planck's constant h. Then pi is the value 3.14. This constant value 3.14 and q is the integral. So this is the angular momentum for a moving electrons. Then next postulates, that is fifth one. The electrons in stationary state do not emit energy. Electrons in stationary state do not emit any energy. It means ಒಂದು ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋದು ಮೂವ್ ಆಗ್ತಿರೋ ಸ್ಟೇಬಲ್ ಆಗಿದೆ ಅಂದ್ರೆ ಒಂದೇ ಕಡೆ ಇದೆ ಅಂದ್ರೆ it doesn't emit energy is the fifth postulate. Then similarly the next postulates, when the electrons jumps from one orbit to two orbit, means from one orbit to second orbit, electrons jumps from one orbit to another orbit. It means higher energy orbit to lower energy orbit, it emits energy. Similarly, if electron jumps from lower energy orbit to higher energy orbit, it absorbs energy. That is called sixth postulate. Means electron jumps from higher energy to lower energy, it emits energy, and electron jumps from lower energy to higher energy, it absorbs energy. Then seventh one, the change in energy, that is absorption energy and emitted energy is given by change in energy delta E, that is equal to emitted energy minus absorbed energy. That is higher energy minus lower energy is the change in energy. Then the next postulate is eighth one. For this emitted energy is given by the relation E is equal to h. From Planck's equation, for this emitted energy is given by or change in energy by Planck's equation is given by E is equal to h nu, where E is the change in energy of an electron and h is Planck's constant and nu is the velocity of a moving electron. Sorry, not velocity, frequency of moving electrons. This is the postulates of Bohr's atomic theory. So after knowing the postulates, we have to know some limitations. Means the Bohr's atomic model cannot be explained completely about the structure of an atom. It fails somewhere else to give complete details about of an atom. So that we are going to study limitations or failures or demerits of Bohr's atomic theory. So the next concept is limitations of Bohr atomic theory. Either we call limitation or failures or demerits, all are same. The first limitation of Bohr's atomic theory, it is applicable only for hydrogen-like atom. It means the uni-electron atoms. So here observe the hydrogen H, atomic number is 1. It contains only 1 electron. And you know lithium, it contains 2 electrons, right? Similarly, if you take lithium ion, when it becomes ion, loses 1 electron. During that time, it has only 1 electron. Lithium ion, like the atoms which having only 1 electron or uni-electron, such kind of atoms only applicable by Bohr's atomic theory. It means it fails to explain multi-electron systems. It means however, except hydrogen, all atoms are fails to obey this Bohr's atomic theory. This is the first limitation. Then second limitation, it doesn't explain the splitting of spectral line into number of fine lines. Already I told you while explaining the line spectrum of hydrogen atom, when we are passing electrons into the photospectrometer, the emitted electron radiations are passes into photospectrometer. It shows like a band, right? So this is called a band. In spectrophotometer, this band is looking like a dark patch like that. We can't see this individual separation of lines. So here, Bohr fails to explain this band is splitting into number of fine lines in presence of electric field and magnetic field. That is, in presence of electric field we call Stark effect, in presence of magnetic field we call Zeeman effect. In presence of electric field we call Stark effect, and in presence of magnetic field we called Zeeman effect. So this band is split into number of fine lines. It doesn't explain by Bohr atomic theory. Then the third limitation, it goes against Heisenberg uncertainty principle. It goes against Heisenberg uncertainty principle. So Bohr goes against uncertainty principle. It means the uncertainty principle says that the change in position and momentum cannot be measured simultaneously for a moving electron or any object. If you take a orbit, this is an orbit. In this orbit, the electrons are moving. This is the center of the orbit. Now observe, if the electrons are moving in an orbit, we can find its velocity. We can't find its position, right? Andre one electron orbital alli move ಆಗ್ತಿದೆ ಅಂದ್ರೆ electron ನ velocity ಅಂದ್ರೆ ಎಷ್ಟು ವೇಗವಾಗಿ ಹೋಗ್ತಿದೆ ಅಂತ ನೋಡಬಹುದು, ಮೆಷರ್ ಮಾಡಬಹುದು. ಆದ್ರೆ ಎಲ್ಲಿದೆ ಅಂತ ನಾವು ಹೇಳಕ ಆಗೋದಿಲ್ಲ, because it is moving in nature. Similarly, if electron is in rest, electron ಒಂದು rest ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ, ಒಂದೇ ಕಡೆ ಇದೆ ಅಂದ್ರೆ we can say the position of an electron, but we can't say velocity of an electron. Okay, that is says that the Heisenberg, but Bohr failed to explain this concept. Okay, so he goes against Heisenberg uncertainty principle, that is delta x and delta p is always greater than h by theta. sorry, not by pi, h by 4 pi. This is the Heisenberg uncertainty principle. Then similarly, the next one, de Broglie suggested that electrons have dual character. Fourth one, de Broglie, the scientist de Broglie suggested that the electrons having dual character, that is both wave character as well as particle character, like particles. So not like particles, like electromagnetic radiations. ಅಂದ್ರೆ electromagnetic radiations ತರನೇ ಈ electrons ಗೆ dual character ಇದೆ, wave character ಮತ್ತೆ particle character ಅಂತ ಹೇಳ್ತಾರೆ. Who? The scientist de Broglie. But the Bose says that the electrons have only particle nature. Bose ಹೇಳ್ತಾರೆ electrons ಗೆ particle nature ಮಾತ್ರನೇ ಇದೆ ಅಂತ. ಆದ್ರೆ de Broglie ಅನ್ನೋರು ಪ್ರೂವ್ ಮಾಡ್ತಾರೆ electrons ಗೆ both particle nature ಮತ್ತೆ wave nature, particle nature wave nature ಎರಡೂ ಇದೆ ಅಂತ ಹೇಳ್ತಾರೆ. So this is the demerit of the limitation of Bose atomic model. These are the some demerits or limitations of Bose atomic model. So after knowing limitations and postulates of Bose atomic model, the next concept is dual behavior of matter. The next concept, dual behavior of dual behavior of matter or de Broglie equation. Very important. De Broglie equation we call or dual behavior of matter. Already you know in the previous class the electromagnetic radiations behaves both wave nature as well as particle nature. Similarly, the matter also behaves both the natures, that is wave nature as well as particle nature, that is shown by the scientist de Broglie. Here the matter associated with wave is called as wave matter, and similarly this wave matter consists of particle. Hence the scientist de Broglie gives a relation between both the wave and particle for a moving electrons or any electrons or any substances. For that he give a equation that is called as de Broglie's wave equation. The de Broglie's wave equation is given by lambda is equal to h divided by mv. Lambda is equal to h divided by mv. This is the de Broglie's wave equation for matter associated with wave. To that we call wave matter or matter wave. Here lambda is nothing but wavelength and h is Planck's constant. M and v is nothing but momentum or mass and velocity. These two products we called as momentum, that is mass into velocity is equal to momentum v. Okay, so this is called as de Broglie's wave equation. Now to prove the de Broglie's wave equation, let's consider the Planck's equation. The Planck's equation is E is equal to h nu. The Planck's equation, let's consider the Planck's equation E is equal to h nu, and that is E is equal to h into mu is nothing but c divided by lambda. You know mu is equal to c divided by lambda. That is what E is equal to h c divided by lambda. Let's take this is one equation 1. And similarly consider Einstein energy equation. Consider Einstein equation. Einstein energy equation. Einstein energy equation, that is E is equal to mc square. This is the Einstein energy equation method, that is E is equal to mc square. Now compare these two. Let's take this is equation 2. Compare 1 and 2. Compare equation 1 and 2. So what you get? The left side is same and compare right side. That is mc square is equal to what? hc divided by lambda. Now c get cancelled. The remaining is mc, that is equal to h divided by lambda. Now find the equation for lambda. So do cross multiplication, that is lambda is equal to h divided by mc. H divided by mc, where c is nothing but velocity of light. Velocity of light. Similarly, if c become c is equal to v when for moving object, So if any object is moving, then we call c is equal to v, that is velocity of a moving object, and c is the velocity of light. Therefore lambda is equal to h divided by m into v, that is lambda is equal to h divided by m into e. This is the de Broglie's wave equation. That can also be written lambda is equal to h divided by p, where p is what? M into v. In the beginning only I told you, that is lambda is equal to h divided by p, where h is nothing but Planck's constant and p is the momentum of an electron or moving object. Now from this equation, that is lambda is equal to h divided by p, that is lambda is equal to h divided by p, right? This can also be written like that is lambda is equal to h divided by p. So from this equation observe, p is inversely proportional to the what? Lambda. P is inversely proportional to the lambda because h is constant, that is Planck's constant. So this is the derivation of de Broglie's wave equation. So very important problems on the basis of de Broglie's wave equation. So problems on the basis of de Broglie's wave equation. So here the problem is, find the wavelength of a 100 gram particles moving with a velocity 100 meter per second. So write the data. Before writing the formula, the data is given. The wavelength, find the wavelength, that is lambda is finding for what? 100 grams of particles. 100 grams is mass, that is m is equal to how much? 100 grams. Then convert grams into kg. Before converting, see the question. Moving with velocity is v, that is velocity is equal to 100 meter per second. This is velocity. So convert the mass into standard unit, that is to kg. That is to conversion, m is equal to 100 grams. To convert kg, that is equal to 100 into 10 power minus 3 kg. Okay, k means 10 power plus 3. So 10 power plus 3 minus 3 becomes cancel. Therefore, or it can be written as 10 power minus 3 into 10 power plus 3 grams. Because 10 power minus 3 plus 3 get cancelled, right? Now that is equal to 100 into 10 power minus 3. 10 power 3 is what? Kg. Now 10 power minus 3 multiplied to this one, you get 0.1 kg, right? It means 100 grams is equal to how much? 0.1 kg, right here. M is equal to 0.1 kg. It means converting grams into the kgs. Now put de Broglie's equation. We know that lambda is equal to h divided by m into v. So when h is nothing but what? Planck's constant. Its value is h is equal to, here they are given, you should remember, h is equal to 6.626 into 10 power minus 34 joules second. This is the Planck's constant, joules second. Now substitute here, that is equal to lambda is how much? 6.626 into 10 power minus 34 divided by m is how much? 0.1 into v is 100. Now so observe, multiply these two and solve. That is equal to 0.1 into 100 becomes 10. That is 6.626 into 10 power minus 34 divided by 0.1 into 100 becomes 10. Now divide 6.626 divided by 10, you get 66.23 or 0. Sorry, how much you get after dividing? 0.666 to 6 into 10 power minus 34. Right. So this can be written as, after dividing, you get that this is equal to 0.66 to 6 into 10 power minus 34. Now this can be written as 6.626 into 10 power minus 35, right? After shifting the decimal, it becomes 6.626 into 10 power minus 35. This is what? Lambda. So what is the unit for lambda? Meters. The wavelength is measured in meters. So that is lambda. This is the value or the wavelength of 100 gram moving particles with a velocity is 100 meter per second. Okay, particles 100 particles another 100 meter per second should move out the wavelength another distributed, so that the particles behaves both wave nature as well as particle nature. Here behaves particles, and while moving it behaves wave. So that is only this characteristic de Broglie says. Similarly, some problems on the basis of de Broglie important practice.